let's get started. Okay, welcome to the analog track, part 2 or maybe part 3. My name is Jean Hunter. I'm from Cornell University. I represent the High Seas Analog Project. And what I'm going to talk about today is just sort of an overview of the habitat and how we got where we are, and what we're doing now, and our plans for the future. So it's going to be kind of free-flowing. So let's see. So an outline, you can read this for yourself. We'll talk a little bit about the habitat, the crew, the food study, some of the other projects that we incorporated into the study to make it into an integrated study, much like a real Mars mission. Our results, which are very sketchy right now because of the huge amount of data that we have and the small amount of time we've had to analyze it, and our future plans, and then some lessons that we hope to apply to the next 3 high sea studies, and also through our continuing relationship with the Mars Society to apply some of those lessons to the Mars Arctic 365. So the High Seas Analog Study was actually part of a larger NASA-funded study, which was a comparison between 2 different spaceflight analogs. One was a bed rest study. Head-down bed rest is a microgravity simulation. This is a NASA stock photo of 2 fellows enjoying, quote, 90 days of 70 days of head-down bed rest. These subjects have very little autonomy. Their whole day is scheduled for them, kind of like astronauts on the ISS. The subjects are mostly male, between 25 and 55, mostly from lower socioeconomic status. But the kinds of questions that we ask them to answer, the studies that we did on them, are very similar to the studies that we did on our own crew. Now, for our analog crew, this was a simulation of the isolation and the day-to-day life on a Mars mission. The planetary portion of the mission, we didn't handle transit. So we had a crew that had considerable autonomy to determine their daily schedule. We selected them to fit our concept of what a Mars crew should look like and the sort of training that they had. So everybody met the basic NASA criteria for astronauts: at least 3 years of professional experience past a STEM bachelor's degree. In fact, the only one of our crew who was a student was our roboticist, Simon Engler from Canada. We had an international crew. Let's see, in terms of nationality, we had a Belgian, a Canadian, and 4 Americans. Culturally, we had more diversity than that because we had a Puerto Rican, we had Oleg Abramov, our geologist, is culturally as Russian as he is American. Cyan Proctor is African American. We had 3 men and 3 women, and everybody was a trained scientist, except one person who's an educator and an outreach specialist. That was Cyan Proctor. So they had the same questionnaires as our bed rest crew, except that their food intake was quite different. In the bed rest study, they are given food to eat, and they're obligated to eat all of it. For our study, they cooked for themselves or ate prepackaged food, but they selected what they were going to eat. They ate when they wanted, they ate what they wanted, they ate as much as they wanted. But we had them comment on how hungry they were before the meal, how full they were after the meal. We measured their food so we knew exactly how much they were taking in. I'd love to take the question, but we have limited time for having gotten started 15 minutes late. So if you could hold that till the end, I'd appreciate that. So the habitat, you can see it here on the slopes of Mauna Loa. There in the distance is Mauna Kea, and up near the top of Mauna Kea is the Mauna Kea Observatory. This was, the habitat site was a disused gravel quarry, so it wasn't culturally sensitive. It was mostly volcanic cinder, but the environs, you can see the gray and the black there, are pahoehoe and a'a lava, mostly fairly recent flows within the last 300 to 500 years. So there was lots and lots of different geological sites of interest there, including lava tubes. So this is a diagram of the first floor of the habitat. It's round because it was a dome structure, as you saw before. I don't have a pointer here, do I? Not a one, okay. But you can see in the foreground at the bottom, there's a common workspace, an open area that was used for exercise, that was used for just plain living space and working space. There's a straight stair that goes up to the second floor, which we'll see on the next slide. There is on the left, let's see, going, I guess, clockwise from the top, we have an area that is storage and resupply and a pantry there. This is actually, thank you.
Sure.
This can be, yes, this can, if we needed to accommodate a smaller crew, we could actually change these walls and make the overall space here smaller. We have a kitchen and dining area here, the sink, the cooktops. Over here we had our food weighing area. We have a very nice lab here with a sink and a built-in bench, and over here we had, this is flexible space. Here we had a table and shelves for doing microbiology work, but you could put biomedical stuff in there if you wanted. A full bath on the first floor, and on the second floor there's a half bath. Okay. We also have a shipping container here, 20 by 8 foot shipping container, where we had most of our storage here, a workbench, some of our utilities like a water pump, and this was the airlock that connected the habitat to our shop and also to the outside. And in here we stored all of our EVA suits. This is the bedrooms above, and you can see there's 6 identical small chambers here, each one about 50 square feet of floor space, and a half bath. And this landing was always full of everybody's laundry. They used to hang the laundry on the banister here and all the way up and down the stairs. Back here is a small laundry. We have a dishwasher here that we used some of the time. Okay. And there was a porthole here so that the crew could look out. Okay. Our infrastructure was completely off the grid. Here you see the photovoltaics and our generator. This is Simon Engler, our crew engineer, in one of the suits that we got from Dave Aiken at University of Maryland, working on the generator. This was a high-gen state-of-the-art generator from Planetary Power Incorporated. It burned diesel, but it came with a huge battery bank so that it could run full out, which is at the highest efficiency for generators, charge the batteries so that we weren't wasting fuel by having it run at a low level to provide a little bit of power. And then on sunny days, photovoltaics provided a lot of our power. This is our transmission station here. This overlooks the saddle area between the two mountains, and it sends a radio signal all the way to the Mauna Kea Observatory, which contained all of our internet service. There was a cell phone in the hab that was kept in a drawer for emergency, but we never used it. So this is the habitat with its infrastructure. Over here is the water tank and the backup water tank. Down here is the sewage tank. Here is the generator and the photovoltaics. And we have a solar thermal hot water heater on the top of the storage facility. And up here you can see the vent, which allows us to get air out of the hab. The air intakes around the bottom. So here's some interior shots from the hab. This is the kitchen, looking past the kitchen island with the cooktop over here to the sink and dishwasher. Here's our range hood. Over here is the food weighing station, and over in this area would be the dining room. This is what one of the the beds looks like, the chambers looks like. I think this is Simon's. These are from his nieces and nephews. This is the porthole, and you can see that even on a bright day, it was much brighter outdoors than indoors. And this is the downstairs bathroom with the shower, the sink, and a mirror. Here's some more scenes from daily life in the Hab. Here is washing the dishes. Here are Jahira and Angelo working out. The crew worked out for about an hour a day. They used the P90X workout tapes. They used the exercise bike, a treadmill. They did yoga, and they also got extra exercise going on EVAs every couple of days. This is part of the work area with some of the robot stuff that we were working on. Here's the crew's shot inside the Hab wearing their uniforms. Angela Vermeulen was a commander. Cyan Proctor, our outreach specialist. Jahira Sierra, science officer. Oleg Abramov, geologist. Kate Green, science writer. And Simon Engler, crew engineer and roboticist. Crew selection and training was a very long and laborious process because we wanted to get exactly the right people for the mission. We started accepting crew applications in December of 2011. The deadline was early 2012, and from almost 700 applications, we winnowed them down to 150. Then we looked carefully at everybody's paperwork, their CVs and so forth, got it down to 30, interviewed everybody on that list via Skype, and we came up with 9 finalists. We brought them to Cornell for a 4-day workshop in which we tested their ability to smell and taste. Okay, here's Oleg and Kate taking our smell test. We gave them cooking lessons. This is Rupert Spies from the hotel school, who's a trained chef. He didn't really need to teach much to Jahira and Oleg because they were marvelous cooks to begin with. But some of our crew didn't have much experience in that regard, and so they really benefited from the training. And we did an afternoon's worth of team building exercises out in the woods near Cornell. And here's our crew who were blindfolded, and it was the job of Kim and myself and Brian Caldwell, the postdoc on the project, to try to get everybody to stand on these 2 pieces of wood and be able to move forward through a narrow gap. That was the last of the exercises, but we got a lot out of that whole experience, and I highly recommend it for anybody that's going to be working together in isolation for a long time. Following these 4 days, we did a down select, and we eliminated 3 of our final 9 for a variety of reasons, leaving us with the 6 who eventually went to Habitat. The second phase of training was at the Mars Desert Research Station, and here you see Jahira with her Puerto Rican flag doing her Spanish language outreach work. They spent 2 weeks at MDRS, and we owe a great debt to the MDRS mission support staff and the MDRS management for making it possible for us to be out there. This wasn't actually what they ate at MDRS. You can tell those of you who have been there can tell this is the wrong table, but this is the sort of thing that they ate. We had them eat prepackaged food at Cornell, and then they had the same sort of thing at MDRS, along with some of their own cooking. When they got to the Habitat, Kim and I had already done the shopping for 4 months for 6 people, and it was up to the crew to sort everything out. You can see that these are their snack bins. Everybody had a snack bin. We gave them freeze-dried and dehydrated materials like freeze-dried beef, crystalline eggs, non-fat dried milk. We gave them backpacking foods. We gave them ordinary pantry supplies, flour, dried milk, oil, shortening, baking powder, sugar, honey, and they sorted that all out. And we also gave them tortillas, which we use at MDRS and are also used on the space station. We had a bread maker, 3 cooktops, a convection microwave oven, a convection toaster oven, a microwave, and a blender. Not too much in the way of cooking equipment, but they were really creative with it. Here's some scenes from cooking. Here's Oleg making, I think this is pelmeni, I think this is Russian dumplings. We had a lot of great Russian dishes from Oleg. This is omega patties made from canned tuna or salmon, and breadcrumbs and crystal eggs and so forth. And on top is, this is dehydrated cabbage, which has been rehydrated and sauteed. This is the favorite bread recipe. It's called Tasty Buns. I think it's from allrecipes.com. And these are some of the sliced dehydrated potatoes, which have been rehydrated and pan-fried to make an analog of potato chips. These are some of the ingredients for one of the more popular dishes, the lemon dill salad. You can see dehydrated broccoli and carrots here. Let's see, rotini, lemon juice powder, pepperoni, freeze-dried dill, and a bunch of other things. Every day, the crew would get up and weigh themselves. They ate 3 meals. They would eat snacks from their snack box. At each meal, they would weigh their food by making a video of it. We had webcams. We had webcams set up at the weighing station, and each time somebody took a serving of food, they would put their plate on the scale, tear the scale, and then start loading the food onto the plate, and we would take a video of that. And I have now 120 days worth of videos. It's each one about 50 megs of AVI video, and I watch those, and I write down the numbers. And it sounds like...
Isn't that what director listens to?
No, it is not, because we needed all the money for the project, and so they also filled out a questionnaire that spanned the meal. Before the meal, they would say how hungry they were. They would look at the food and smell the food and decide how appealing this food looks to them. And after the meal, they would say how well they liked the food and how full they felt. So we have 120 days times 3 meals plus snacks of those surveys that are being entered in by, not by me, by a data entry specialist. And so we're just getting started on analyzing that data. The surveys that they're filling out are exactly the same ones as we're getting from the bed rest subjects. So we're going to be able to compare how menu fatigue works in an ad lib eating environment with a totally planned eating environment. And we'll be able to compare how the crew reacted to their food on cooking days when they could be as creative as they liked with their ingredients versus non-cooking days in which they were only permitted to rehydrate, heat, and cool their food. So typical things to eat on a non-cooking day would be cereal and rehydrated non-fat dry milk for breakfast, maybe with some freeze-dried strawberries on top. For lunch, maybe soup and a tortilla wrap sandwich. For dinner, some of the number 10 cans of long-term storage entrees. In addition to the food study, which definitely did not take up that much time, we filled the rest of the crew's time with EVAs and with opportunistic research and with their own research. We had a number of crew projects. One was on sleep and light. This is a Zeo sleep recorder, and the crew was exposed to blue light in the mornings or not on a statistically designed schedule. And this device recorded their sleep and the stages of sleep and the sleep quality, and they filled out surveys about alertness and sleepiness during the day. Oleg brought some infrared false color software and an infrared camera along. And here what you see is the entrance to a lava tube here. And you can see that here, where the sun is shining on the lava, it's very, very warm, but inside the lava tube, it's quite cool. And so he took these pictures of the hab inside and outside and the surrounding area. Simon Engler worked on robotics. He had a rover here and 2 robotic pets. Jahira's research was, part of her research was on antimicrobial textiles. Thank you. And so these are 2 socks that 2 of the socks that the crew wore. One of them is antimicrobial treated and one of them is not. Okay? Nobody knew which one was which, but they started wearing the socks, and at the end of every day they would evaluate the sock, and when the sock just got too horrible to wear, they would retire it and get another sock and wear that. So we had a comparison between antimicrobial and non-antimicrobial textiles of various kinds, partly courtesy of Cupron, partly courtesy of the NASA Advanced Food Tech Lab. Results and future plans. As I said before, we're knee-deep in data. Well, we're actually eyeball deep in data. This is some of our food data from the end of the day questionnaire. So here, these are mood data of one sort or another. These are the days. We start on the 9th and we're going through the 14th. These are the snacks that people didn't weigh in. Here are everybody's crew numbers. You can see that we are still working on cleaning up the data. This is data from our telemetry system. We had great telemetry from Bill Wicking of Hawaii Preparatory Academy. This shows in green the CO2 content of the outdoor atmosphere, and in red the CO2 content indoors. We had a fan rigged to this sensor that would turn on the fan whenever the CO2 concentration got above 600 parts per million or the temperature got too high. Oh, and then we have that sort of telemetry for power, for water flows, temperature and humidity, and water level in tanks. So we can back out now the relative resource utilization on cooking days and non-cooking days. The preliminary results that we have are mostly feedback from the crew. They tell us that in their view, being able to cook what they liked and cook for each other was a huge morale booster and essential to their psychological well-being inside the habitat. And we'll be following up on that claim, that assertion, as we go through the data, and we'll try to see which aspects of the data back that up and which aspects of the data may undermine that claim, and which aspects of the data neither support nor undermine that claim. What we are really trying to show is to get a fuller picture of the effects of crew cooking for themselves. Do they eat more? Do they eat better when they cook for themselves? Are they happier when they cook for themselves? On the other side, how much more power and water do they use when they're preparing something elaborate than when they're just reheating something or rehydrating something from a number 10 can? So if we do send people to Mars, we're not going to send them up there to cook and do housekeeping. We're going to send them up there to do science and to explore. So there have to be trade-offs between the psychological and nutritional advantages of a crew-cooked food system versus the convenience and the low resource demands of a prepackaged food system. So even if our psychological results are inconclusive, and we really won't know for another couple of months, we will have some hard data on resource utilization that can go to the mission planners so that they can do equivalent mass, system mass calculations for these food systems. We're also developing a spreadsheet model of a bioregenerative food system, a bulk packaged ingredients food system, and a prepackaged food system, so that for any given mission design, duration, crew number, and location, we can estimate the relative mass costs of the 3 different food systems or of some sort of hybrid food system. So we came out of this with many more qualitative lessons than quantitative lessons, at least so far. And the lessons we learned was that the better you plan, the more smoothly things go. We had a number of, we had some troublesome times in this grant negotiating with NASA about building the habitat. In fact, NASA would not let us build the habitat on the grant. We had to go find another donor, a donor to build the habitat for us. Without Blue Planet Foundation, I wouldn't be here today. So we were learning as we went, and so we weren't actually able to have everything working well in advance. When we do this the next 3 times, that's going to be much less of a problem. It's important to work and train together thoroughly before the mission starts, so that you know what to expect from other people. You know what their hot buttons are, so you can avoid pressing them. You know if somebody complains that, well, that's just what they're like, they like to complain, or that if someone else complains, there's really a problem because this person never complains. We learned to be patient and kind with each other, and not to expect anything quick. That is, the crew to expect anything real quick from the ground, or the ground to expect anything real fast from the crew. People take time to process requests and uncertainty. Start data analysis early, because there's always going to be more data than you have time to analyze. And get expert help early and often. We found time and again that we didn't have enough expertise to do everything exactly as well as we wanted to, but we were fortunate to be able to call on our network of people who knew how to do various specific things, bring them into the team, and learn from them and have them help us out. So there are many, many people to thank. Quite a few of whom are here today. The High Seas crew isn't, but we have Susan Jewell, and from the first tier support crew. Stevie Foss is here from the MDRS mission support crew, and Shannon, and probably other people that I don't recognize. John Baranka, of course. I'm bad at faces, so please forgive me if I leave you out. Also, Blue Planet Foundation for the HAB, Hotel Administration for the cooking lessons, Hawaii Preparatory Academy for the telemetry, NASA Communications Group for the 20-minute delay, NASA Advanced Food Tech Lab for information on how astronauts eat, Advanced Clothing Tech Lab for the antimicrobial textiles that we studied, and also NASA for the grant that made this all possible. I have maybe a minute or 2 for questions. Okay, now you were the first to hand yours, so I'll call on you first.
What's SES?
Socioeconomic status.
Ah,
Yeah.
And were there, it seems as obviously yes, but were there any serious negative health effects from that bed rest?
That bed rest, I can't answer that question in the time that we have. There are serious effects because it's equivalent to 6 months of, it's equivalent to several months of microgravity. But NASA is used to running these studies. They run them all the time. So we were just part of a complement of scientific studies on a given set of bed rest people. Yeah. Next question, in the back.
30 seconds.
30? Okay.
So one more question.
So I saw you did the blue light.
Yeah.
Have you guys been looking at red light? Obviously, that's what you're going to get more on Mars. People use that sometimes actually facilitate going to sleep.
Right, we did use some red light in the evening on some days, and that was designed to meet the study. One more, Ayako.
How did you organize fresh food? Did you
We didn't have any fresh food at all. Okay, we, based on our experience from MDRS, we calculated what we would need for 4 months with 6 people. made some allowances for what we knew that the crew liked and put that out there. Certain things we did have to resupply, other things we had too much of, but that's going to be true anytime. So I would love to talk to you later. Please, please find me.
So take one more.
Okay, one more, thank you.
Is the data going to be available to the public?
Is the data going to be available to the public? This is not open source data. We're academics, we have to publish or perish. But we will be publishing on every aspect of the study that is publishable. You know that for the Mars 500, some of those papers are just now coming out. So if you can be patient and wait 6 months to a couple of years, we'll be reporting on these in technical meetings, publishing in, say, advances in space research, appetite, you know, wherever good space papers appear. AIAA journal. Yeah. Let's say, someone who hasn't asked yet. Yes.
How is those foods compared with the one publicly made available on the ISS?
Hey, the genuine, we weren't able to use the genuine NASA food available on ISS because it's so expensive to prepare that we would have spent our entire budget on that food. It wouldn't have been able to give them power to heat it up or water to put into it. So we used commercially available backpacking foods from Mountain House, from Alpine Air Gourmet Reserves, Backpackers Pantry. We used dehydrated ingredients from Harmony House Foods, freeze-dried from Thrive, Oregon Freeze Dry, and so forth. So all of these are available on the consumer market. You can find them all online.
But are they completely different from what?
It's definitely different from what they have on orbit. We weren't too concerned about that. We can go back, perhaps, and use genuine NASA foods later. This was, in a sense, a pilot study. When you do analog research, you try to pick the things that are going to be most important to get exactly right and get them right and let everything else kind of slide. So that's what we did.
Quick question. Does anybody remember the magic F key you hit to make it recognize it? F8.
Yes, Susan.
Jean, it was wonderful working with the team and evaluating all the events a lot. So my question is, for the next mission, what have you got planned in terms of the science? Are you going to continue with what you started here, or are you going to have a whole new set of science next year?
Well, Kim Binstead has been funded for 3 more years of this work, but under behavioral health and performance. So the next 3 years of studies are going to center on team dynamics, leadership, and the changes in team structure and roles over a 4, an 8, and a 12-month mission. But again, to make the isolated environment faithful to a real astronaut experience, we're going to have to keep the crew exceptionally busy, just like the current crew, the just past crew. So they're going to do elements of the food study, depending on how our data falls out. We will pick the elements that we really want to explore in more depth to do, and we'll have other opportunistic research for them to do, for example, testing of life support equipment.
What is your specific field, Gene?
My specific field, it's hard to explain. I was trained as a chemical engineer. I work in biological engineering. I consider myself a space life support engineer. Yes.
The socks.
Yes.
What were the substances that were being tested as the antimicrobial? Were they silver or?
There were copper ions, and then there's a proprietary polymeric treatment that I don't really know what's in it, but we had to submit the data, the MSDS, to our IRB to make sure that we could use it. So there's a launder-in treatment, and that was one of them. The copper ions are another. We also had exercise wear, exercise T-shirts made of different fabrics with different antimicrobial treatments that we got from NASA, because they're testing those out on JSC employees and our crew to find the best ones to use on the space station. Well, I think I better turn this over to Bruce, because he's got a fascinating presentation, and he deserves the time to, enough time to actually share it with us.
Thank you, Dr. Hunter. And for everybody, these two tracks are approximately 15 minutes behind, so if you were trying to go back and forth, it should be okay. Just if you're trying to cut the other one, it's straight down the hall at the end.
Yes.
Scholarly expenditure.